Synthetic division. This is what, you know, kind of a shorthand notation of polynomial long division. We're going to use the synthetic division to divide 4x to the fourth minus 2x squared minus x plus 1 by the x plus 2. Okay? So I'm going to do something. I don't need you to make a bunch of noise. Just watch. No, just watch. I got a remainder of 59. Is this or is this not a factor? No, it's not. That's what synthetic division is. Okay? Now I'll go back and walk you through it. But I just want to show you. The point of synthetic division is that it's much faster, much easier, much quicker, and it is kind of a cool technique. Let's do this. I'm going to set up the calculator for now. Okay. I'm going to need some help with you guys type that in, but okay, would somebody please, what's the first term? 4x squared? 4x to the fourth. Okay, so I put negative 2 in there. Oh, no I didn't. I put x in it. Oh, no I didn't. Whatever, 4. 4x to the fourth. So I put negative 2 in for x. What's the next term? Negative 2x squared? So negative 2. And again, I'm going to put negative 2 in for x. So negative 2 squared. What's next? Minus x. Okay, so minus, remember our x value is set at negative 2. So minus a negative 2 and then plus 1.
Wait, where'd you get the negative 2?
What happened?
I got 50.
You're supposed to be writing. Error. The last one isn't supposed to be squared.
I think when somebody read it to me or something. Messed me up. 4. Negative 2. Raised to the fourth. I need to get out of there. Then it's minus 2.
That's what we went last lesson.
Oh. Minus 2. Then we put negative 2 in here. And we are squaring that. And then I go minus negative 2. And then plus 1. So what did, by plugging in negative 2, what did I get?
59.
Yeah, 59.
Where'd you get the negative?
Yeah.
Okay, I'll go back to where I got the negative 2 in just a second. But how many of you are real comfortable if somebody gives you the number, 5, and you're taking it to the fourth power and plugging it in by hand? It actually is kind of cumbersome plugging it into the calculator. Look at the synthetic division to be able to get the same number as fast as I did. And it doesn't take much effort for you guys to get pretty good at doing synthetic division. So, where did I get the negative 2? This is first degree, or oh my goodness, or linear. We're only going to use synthetic division when it's a linear factor. We're not using it for dividing by x squared or x cubed. So if it's a linear factor, we can use it. And the easiest way for you guys to understand what to do is to set it equal to 0. Subtract 2. So when somebody says, is x plus 2 a factor? What they're really asking you is, does the graph touch the x-axis at negative 2? So negative 2 is the value that we're testing. So that's why I put negative 2 out front. Now there are different ways to draw up synthetic division. Some people will put some people put, I think they just go like a T here. You know, I don't really care how you do it. And there's something wrong today with. But anyway, what I'm doing is the 4 will always, that first number just falls through on synthetic division. Because my x has a 1 in front over here. So we technically are dividing by 1, so it's just going to go through. But it's kind of like when you're a little kid. You take the number that's out here, that's -2 times 4, and I get -8. Then I squish them together. What's 0 and -8? It's -8. Oh, where'd the 0 come from? Good question. The x cubed, right? There's no x cubed in the problem.
Oh, so there's.
So we use the 0 as a placeholder. Yeah.
Oh, I see what you're doing now.
So that you always need to play. Remember how careful I was on the previous problem to line up like terms, right? Everything was a like term, top and bottom. And without doing this, you'll mess things up. So 0 and -8 is -8. Then you multiply by the -2 again, and I got 16. You squish them together, you get 14. You multiply by -2, you get -28. -1 and -28 is -29. Multiply by -2, you get 58. And you just keep going through the process until there are no numbers left. Now, I put this little square around the 59. That last number will always be your remainder. That's always the remainder. Then, that tells me right there that it didn't go in evenly, so it's not a factor. This will be your constant. This will be your x. This will be your x squared. This will be your x cubed. And it just, you know, depending on how large of a polynomial, you just keep working and adding a degree to those terms. So that last number is your remainder. The next one will be the constant. The next one is x squared, x cubed, x squared. Okay? So that's synthetic division. Or you can plug that in, go to a table and look to see is there a 0 at -2, or you can do what I did and plug -2 in to see if it makes the function 0. Because that's really what you're checking. Does this number make the polynomial 0? So that's what this remainder theorem right here is telling us. So do f of 5. That's what the remainder theorem is talking about. Do f of 5. So what is 4 times 5 squared minus 10 times 5 minus 21? What's 5 squared? 25 times 4. What's negative 10 times 5? Negative 50. Minus 21. 100 minus 71 is 29. So when I plug in 5, does it make the polynomial equal to 0? No. So what do you know? That x minus 5 is not a factor. If I do the same thing with synthetic division, 4, negative 10, negative 21. Now remember, this is kind of the reverse. If x is equal to 5 as the value, we're talking about is x minus 5 a factor? Because you bring the 5 back to the x, so you subtract it back. So you got to watch for that. So we're going to put the number 5 out here. 4, 20, 10, 50. I don't know, which one's easier for you guys to do in your head, the blue or the green? Now the green with the calculator works just as easy because you let the calculator do all the work. But mathematically, it's actually, I think the blue is very quick and easy to determine what's the output when I plug this number in. It's kind of weird. Okay, so do the same thing. you have a choice. You can plug in, remember, they're saying whether or not x minus 1 is a factor. So I want you to determine whether it is a factor or not. Do that now. What are you going to do? It is. I'm done. What did I do? They're asking me, is x minus 1 a factor? So I said, okay, well, when I set that equal to 0, what they're really asking me is 1, the value of 1. When x is 1, does that make my polynomial 0? In this case, it's a lot easier for me to plug it in and then do the work, right? I'm done in nanoseconds. If you are going, in this case, if you're going to set, oh yeah, I am, nanoseconds. If you're going to set up synthetic division, what has to happen? Okay, so we put the 1 out front. What goes here? 1, x cubed, x squared, x. So by going to synthetic division in this case, it actually creates more work. So the 1 will drop through. 1 times 1 is 1. 0 and 1 is 1. 1 times 1 is 1. 0 and 1 is 1. 1 times 1 is 1. 0 and 1 is 1. 1 times 1 is 1. Finally, I get my remainder, and it is a 0. So whether you look at the synthetic division or you look over here at the function notation, they both tell me that the remainder will be 0. Here, we're always adding these numbers together, add them there, and then out here, we're multiplying. So the outside numbers are always getting multiplied, the inside numbers always get added. Okay, so looking at these two problems, the final thing we can do is say that x to the 4th minus 1 is what I started with. What did we divide by? We divided by x minus 1. And what was our answer?
0.
What was our answer? 1x cubed plus an x squared plus an x plus a 1. And what's the remainder? 0. So remember, this will be your constant. This is your x. This is your x squared. This is your x cubed, because that number right there is your remainder. So mathematically, what we're working on is finding all the zeros of a polynomial. So I started with an x to the 4th. What could I do with this x cubed? What techniques do you guys know to work with x cubed plus x squared plus x plus 1? You could try your, factor by grouping. You guys call it splitting in half or something. Factor by grouping. Or maybe you could do synthetic division again, right? So the point would be, now that we have one factor, we're going to try to break down this cubic into more factors. Okay?